So what we did yesterday, we defined what a population and what a sample is, and we said the population is a collection of all outcomes. And we gave an example, all students taking math 141 at Henry Ford College. And the key word, guys, here just to recognize whether a statement represents a population or a sample is all. So when it refers to everybody, it is a population. And we defined a sample. And we defined a sample to be a subset of the population, which is a part of the population. And I gave you an example here. Some of you said, like, an example will be female students taking math 141. This is a subset. Male students taking math 141, that would be a part, just of the population. It's very important to understand the difference between population and a sample. In statistics, we use data from samples to draw conclusions about the population. So this is how statistics work. Then we defined what data is. It consists of information, observations, counts, measurements, etc. Then we defined what a parameter is. We said a parameter is a number that describes population characteristics. It comes from a population. It represents a population. And I gave you an example, the average age of all the people in the United States. So that comes from a population. And then we define a statistic to be a value that describes a sample. And this is what we call statistics without the S. It's a numerical description of a sample. And then I gave you an example, the average age of people from a sample of 3 states, not all the states. That's why it becomes a sample. Did we do anything else, guys? Did we do the difference between descriptive statistics and inferential statistics, if you recollect?
We did a lot.
I think we stopped at the university one.
Oh.
Yeah.
We did qualitative and quantitative data as well.
No, we didn't do all this.
Yes,
we stopped
okay,
at the other page.
Yeah, I think so. You're right. Okay. How to distinguish between descriptive statistics and inferential statistics. For your information, guys, the first 5 chapters are mainly descriptive and the remaining chapters are inferential. And mainly the most important part in a statistics course is the inferential part, because you learn how to draw conclusions about the population. Descriptive statistics, I think the word explains it, guys. It describes data. Like your schedule, if you have your schedule in a table, that's descriptive statistics because you have it presented in a table. Organizing data in tables, pie charts, bar graphs, histograms, etc. Summarizing and displaying data. So that's what descriptive statistics. And I gave you some examples, tables, charts, an average. And let me tell you what inferential statistics is. It's making an inference. You use a sample to make an inference about the population. That's what inferential statistics. And let's give this example and show you how you can tell which is which. Decide which part of the study represents a descriptive branch of statistics. What conclusion might be drawn from the study using inferential statistics? So here's what he gives us. A large sample of men aged 48 was studied for 18 years. For unmarried men, approximately 70% were alive at age 65. For married men, 90% were alive at age 65. What would be the descriptive statistics? The descriptive statistics would be this. That's a display, which says 70% of unmarried men were alive at age 65. And here it says 90% married men were alive at age 65. That is the descriptive statistics. They usually don't tell you guys what the inference is. You have to make the inference. What kind of inference can you make out of this? What's the conclusion? What are you inclined to say here?
Married people live longer.
Yeah.
Yeah.
The married
I'd
people.
say the same.
Now, whether this is true or false, I don't know, but that's the conclusion. Married people tend to live See, that's the inference that you make based on this. Now, whether this is true or false, that's a different story. We have to support it later when we come to new chapters. You learn how to support a statement. You
Is that
can't.
the right answer?
What is it?
Is that the right answer?
Yeah. I mean, there is no right or wrong answers. It's just this is my interpretation of what I read. That it seems to me like married men tend to live longer. That's what this says. You will learn later, guys, how to make claims and support the claims with data. And we can verify later in the course whether the data that we have is really supports what we think is happening. Okay, that's all for section 1.1. Section 1.2 is an easy section. It's just you learn how to distinguish between qualitative data and quantitative data. Quantitative, guys, means a number, a quantity that you can add, subtract. Qualitative is not a number, it's an attribute. And qualitative data consists of attributes, labels, and non-numerical entries. And these are some examples of qualitative data, guys. Measure, place of birth, that's a qualitative, that's a name. Eye color. Can you guys come up with some more examples of qualitative data?
Head size.
Skin color.
Then the head size you can add, subtract here. That will be a number. When you measure, it's not qualitative.
Gender.
Gender,
Skin color.
Height. Oh no.
skin color.
Weight and height.
Weight and height will not be qualitative. It's a number.
Oh.
Religion,
Weight is.
Hair color.
hair color.
Sir.
Yeah.
Yeah, anything, guys, you come up with that turns out to be a quality, not an actual number that you can work with, it will be qualitative data. All right. Quantitative data. It's a numerical measurement or counts. And what you guys said earlier will fit there. So age is an example, weight of a letter is an example, temperature is an example. We said height of a person is another example. Weight, we already have the weight. Income,
Pro.
number of students present in my class. As long as it is a number that you can crunch, guys, add, subtract, etc., compared to other numbers, then it is quantitative data. So that's what quantitative and qualitative.
Damn neat.
All right. Levels of measurement. Numbers, guys, fall under four category. Data falls under four category, whether it is quantitative or qualitative. So there are 4 levels of strength of the data, and I'm going to show you what the 4 levels are and give you an example under each level. So we're going to begin with the first level of measurement. It's called nominal level of measurement. Data at the nominal level is qualitative and mainly labels and names, and you cannot rank data, so you cannot sort data in order at this level. And I'm going to give you some examples. Anything qualitative, guys, that you cannot sort out, rank like from smallest, largest, or categorize, just rank it as first, second, third, that will be nominal. Religion, color. I mean, if I ask you to list some colors for me, you cannot say that I have to put, just black or red or green first, because there is no ranking here. You can just list them in any order that you want. Now I'd like you guys to give me an example of nominal level data that has numbers, but we don't use them as numbers. They're not actual numbers, they're just labels. Can you think of something? Something that is qualitative, it has numbers in it, but the numbers are not actual numbers, they're just labels.
Zip code.
Okay, zip code,
Phone number.
phone number. Well, there is one important number that each one of us has one. It's unique to us.
Social security.
Social security number.
Credit
We
card
call it
number.
You said what?
Credit card number.
credit card numbers, yes.
Fear.
Your ID, your student ID also falls under nominal. You know that you don't sort them out and rank them from smallest to largest. You just can't do that. So these are examples of nominal level. Let's go to ordinal level. Ordinal level, guys, is a qualitative data, mainly qualitative. It could be quantitative that can be ranked, arranged in order, smallest to largest, largest to smallest. But you cannot subtract two data entries if they are quantitative. Can you guys think of an example of some qualitative data that can be ranked? Rank means put them in prioritize the first, second, third, fourth, etc.
Religion.
Eye color.
No, you can't rank religion.
Eye color.
Not even the eye color. That wouldn't work here.
Ages.
Someone
Age-
said
Age is a
ages.
number. It's quantitative.
Age will become quantitative.
Country populations.
Number quantitative.
I want something that is qualitative and can be ranked.
Someone said rankings in a race. Does that apply?
No, but because you can't just which race is gonna come first. You can't.
No, not race. I'm talking about like first place in a race.
Oh,
Like
oh
I'm
yeah,
running.
oh yeah. That can be ranked. Yes, if you
Okay.
state it this way, that will work. Yeah, that like the first car, you're not just to win the first place, the second, the third. You just put the names and rank them 1, 2, 3. It will become ordinal. But I'm gonna give you an easy example, guys. Letter grade. Do you guys agree that these are letters, not numbers?
Yes.
And A, B, C, D, E, etc. These are ranked. I give you another example, educational attainment. And I'll explain that in a second. Like the terminal degree that someone can get to, the highest one is PhD, then a master's degree, then a bachelor degree, then associate degree, then high school. You can think of this as an ordinal level. So any words, guys, that you can rank them, and someone mentioned like in a race, if you list them like that, first place, car 1, second place, car 2, this example will become ordinal as long as you rank them. And here is another example where we distinguish between the two. Two data sets are shown. Which data set consists of data at the nominal level and which data set consists of data at the ordinal level. Let's read. Okay, top 5 TV programs, guys. First one is American Idol Wednesday. What do you think this one is?
Ordinal.
Yep.
Wait, what's ordinal again?
Ordinal is qualitative data that can be ranked 1, 2, 3, 4, 5.
And nominal is quantitative numerical data.
No, qualitative, but cannot be ranked.
Oh, all right.
Just labels. Labels with no ranking. Here they're listing TV stations and not in any order. There is no order here. If there is no order, guys, it must be nominal. So that's the difference between ordinal and nominal. The next one we're gonna get to, it's kind of interesting one, but the most important one to us is the last one. That's the one that most of the data will fall into. Number 3, let's see if our students can come up with an example for 3. No more qualitative data. And actually in statistics, guys, we're mainly interested in quantitative data with numbers. We need numbers, not attributes. So interval level of measurement, it's a quantitative data. Data can be ordered. So you can rank data from smallest to largest. You know, if you have numbers, you can put them in order always. Difference between two quantities have a meaning, but the zero represents a position on a scale. So at the interval level of measurement, guys, the zero doesn't mean nothing. It means something. It's something that we feel. It has a meaning. Like if I tell you I have $0 in my wallet, that means I have nothing. But at the interval level, the zero means something. It's a position on a scale. Can you guys think of an example of a quantitative data where zero means something?
Temperature.
Temperature, that's the most important example. You know, 0 degrees for me in the winter time is better than negative 20 degrees Fahrenheit. And there have been times where we went below zero. I would prefer a 0 over negative 20. And I prefer positive 20 over a 0. So 0 means something on the scale of temperature. That's one example, guys. Try to memorize these examples as an important one for the interval level of measurement. I can give you another example.
Can you repeat that same example?
Yeah, temperature, you know, 0 doesn't mean that there is no temperature outside. 0 means it's cold, but it's better than 20 below 0 or 30 below 0. So 0 means a temperature. It's a scaled, you know, just temperature.
The Celsius and Fahrenheit can both be up and
Well,
down.
it doesn't matter. It doesn't matter. It could be either one. 0 is a 0.
R.
The other example will be year. You know, guys, we use Gregorian years, and we're in 2021. There was a year 0 before. That was before Christ and after Christ. So the year 0 means something. It doesn't mean like nothing existed at that time. So year, you could think of it, guys, as another example of interval data at the interval level. Yes, the students is asking me about time. If you mark time on the 24-hour clock, yes, you can think of it as interval, because you know what that means on the 24-hour clock. What does a 00 mean when it turns 0?
12.
It's midnight. Yeah, it means something. It doesn't mean no time. So, but if you think of time by other means, no, it won't be interval, unless if you think of it on the 24-hour clock. Okay, that's the interval level of measurement. Just keep in mind that the difference between the 3 and 4 in a few seconds, it's going to be that in 3, the 0 means something. In 4, the 0 means nothing. Ratio level of measurement, that's the top one. That's the most important one. It's similar to interval level. 0 entry is the inherent reason, implies none, means nothing. And you can compare the data at the ratio level by saying one is twice as big as the others, or one is twice as small as the other. That's what the ratio, that's what the word ratio means, ratio comparing two quantities. And let me give you examples. Actually, anything you think of is going to turn out to be ratio. Height, weight, age. Like, if a person is 8 years old and another person is 16, you can say that 16 is twice as old as the 8. So that makes sense. 0 means nothing. If the weight is 0, means there is nothing. If the height is 0, it means nothing. Income. I don't know if you can come up with some more examples, guys, of ratio level. Sharing with me. Let's see in the chat.
About money.
Yeah, it is.
Oh, income. Sorry, my bad.
Yeah. Yeah, the grade, if you take it as 1, 2, 3, 4, that is correct. You can do that. So ratio is the most popular level, guys, of data that we collect. And that's what we will be using most of the time. So I'm going to give you an example, guys, and tell me which is which. Two data sets are showing which data set consists of data at the interval level, which data set consists of data at the ratio level. Let me project this. It shouldn't be too hard to tell. Okay. New York Yankees World Series victories in years. These are the years. So what do you think the year is categorized as? We mentioned that earlier. Interval or ratio?
Interval.
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 You got it. It's a little bit hard to come up with examples at the interval level. Actually, in my earlier class, a student said sea level, and I agreed. Like a city is 100 feet above sea level, 100 feet below sea level, at sea level. At sea level means zero. Zero means something here. So you could think of it as an interval. You can make it up. If you make it up, it will work. Okay. These are the home run totals, guys. Baltimore has 160 home runs. Like, let's say Chicago has 80 home runs. You can say Baltimore has twice as many home runs as Chicago. So what do you think this is called?
Ordinal level.
No,
Ratio.
Ratio.
ratio level.
Oh,
Can you differentiate? So interval
Is a number where zero means something. Ratio is a number where zero means nothing. Like if Baltimore has 0 home runs, that means they have no home runs at all. Just the zero. The zero is the big deal here. At the interval, and there are not too many examples at the interval level, guys, whereas a ratio is most of the data fall under ratio. And here is a summary of the 4 levels of measurement, guys. Nominal, you can put the data in category qualitative data. You cannot arrange the data in order. You cannot subtract. Subtraction has no meaning. For example, if I say eye color, you tell me brown, yellow, green, black. If I do yellow minus green, what does that mean? It means nothing. You can just subtract, you know,
so
just
interval and ratio are quantitative,
yes.
and then
Exactly.
ordinal and nominal are qualitative.
Most ordinal can be quantitative, but like something you make up first, second, third, fourth ranking, then will become quantitative.
Nominal means you can't rank it, right?
No, you can't. Yeah, exactly.
Got it.
You got it. Ordinal, guys, yes. The difference between ordinal and nominal, you just can't rank it. That's it. Then interval, it's quantitative. It's a number. You can arrange data in order. You can subtract, but you cannot say one value is a multiple of another. And I'm going to give you an example why. Okay, let's say, guys, the temperature in Detroit now is 40 degrees. And let's say the temperature in Las Vegas is 80 degrees. Let me ask you this question. Does it make sense that you can say that 80 degrees is twice as warm or as cold as 40 degrees?
No,
It doesn't.
it's temperature.
You're comparing apples hot with cold, guys. You cannot say that with temperature. And I'm going to give you even a better example. If it is 1 degrees in January here and another degrees in the next city, 2 degrees. You cannot say that 2 degrees is twice as cold than 1 degree. Actually, it's not twice as cold. Actually, it's better. It's 1 degree higher. And so the comparison this way doesn't work with temperature. And be honest with you guys, whether it is 1 degrees outside or 2 degrees, you're not going to be able to feel the difference between the two temperatures. It's very much, you know, the same. So it doesn't mean that this is actually 2 degrees is, if you want to think about it, it's better than 1. It's less cold than the 1 degrees Fahrenheit. But here it says 2 is twice as cold as 1. That's not, doesn't make sense. The only time where you can compare ratios is you can compare this way is with ratios. For example, if someone makes $20 an hour and another person makes $40 an hour, definitely it makes sense to say that this guy makes twice as much as that guy. It does make sense, but it doesn't make sense with temperatures to say that. All right. So that concludes section 1.2. After I'm done with the 3 sections, guys, I'm going to go to the book and do some practice exercises together on this, just to enforce what you learned. All right. What we're going to learn in section 1.3, the objectives. How to distinguish between an observational study and experiment. We'll get to it. How do we collect data? We're not going to collect data. We're not going to learn about collecting data and do that, guys. We're just going to touch on it, but we will not be collecting any data this semester. The data will come to us from the exercises. And we're going to learn how statisticians decide on the sample. How do they select, their sample? When they want to survey a population, how do they select the sample? That's very important. That's what we're going to be learning in this section. Okay.
So, Professor.
Yes.
Quick question. You know the chart with the home runs that you were mentioning earlier?
Mm-hmm.
If we rank those from most to least home runs, like the most at the top and the least at the bottom, wouldn't that?
And it will become ordinal. If you can make it, as I told you, you can make it to be whatever you want. If you're talking about ranking, you don't put the numbers, you just put the names of the states, and then it will become ordinal.
Okay.
Yeah, but the question was not about who
We'll
got
call
the
it-
highest. It's just numbers. I threw numbers at you and I asked you what was the said ratio. But that's a good question. All right. How do we design a statistical study? When statistician guys want to design a study, this is what they put, and you will not be assessed on that. I'm just going to give you an overview. You have to identify what do you want to get out of the study. For example, if I want to survey students about how many courses or how many credit hours they're taking this semester, then I know what I want. I want to ask in this question, how many credit hours you are taking. So identify the variable of interest. You could be surveying students on more than one item, so you just identify more than one variable here. Develop a plan for collecting data and make sure that the data represents the entire population. Collect the data. We're going to learn about the method of collecting data today. Describe the data, present the data in a nice way, in a table or a graph. If you guys attend any presentations about data, you will not see raw data, scattered all over the place. People will put it in a nice format, so it will be appealing to the eye even to look at. And then what do we want from the data to make a conclusion about the population from the data? So this is what a statistical study is. Okay. How do we collect data? There are 4 methods of collecting data, and we're going to learn about each one of them. The first one is called observational study. And let me show you an example right away. Here's what observational study means. A researcher observes and measures characteristics of interest of part of the population. The guy will sit down and take notes. That's what observational study. You just observe and take notes. And here's an example. Researchers observed and recorded the mouthing behavior on non-food objects of children up to 3 years old. So they want to monitor, how children react, just to plastic non-food objects. When they put them in their mouth, what do they do with them? They just watch them and take notes. You don't interfere. You don't ask questions there. That's the first way to do it.
They spit it out.
Second example is experiment. This is another method. And actually, guys, how they came up, just like Pfizer or Moderna with a 95% efficacy rate, it was through an experiment. What is an experiment in statistics? You bring 2 groups. One group will get the actual treatment, the actual medication for vaccine. It was the actual vaccine. And another group will get placebo, which is a sugar pill. You don't tell them that probably got, just the vaccine. You just give people the impression that they did, but they didn't. You monitor the two groups, and then you take notes, just of the groups, just the percent of people, just who got, just the virus. And then that's how they came up with the 95%, efficacy rate. They found out that out of each 100 who took the vaccine, 95 did not get the virus, and 5 got the virus. And that's how they figured it out. It was a 95%. So here's another example, guys. An experiment was performed in which diabetics took cinnamon extract daily while a control group took none. After 40 days, the diabetics who had the cinnamon reduced their risk of heart disease while the control group experienced no change. So it's two groups, guys. One is called control group, will get no treatment, because you need to compare, just your results with something. And then the other group will get the actual treatment from the experiment. Any questions about the experiment? So just keep it in mind, guys. Experiment involves two parties. One party gets, just the actual treatment, and another one gets nothing. Survey. Survey is, just it could be in any format. It could be done by interview, internet, phone, mail, email. It's an investigation of one or more characteristics. You could have more than one question on a survey. I'm very sure, guys, that you have filled out surveys in the past, and anything that you do, you're asked to fill out and submit is called a survey. Example. A survey is conducted on a sample of female physicians to determine whether the primary reason for their career choice is financial stability. And the last one, so we learned observational study. Just keep that in mind, because you're going to have an example right after this. Then we did experiment, and then we did survey, and now we're going to do simulation. Simulation, guys, you use a mathematical physical model to reproduce the conditions of a situation. When it's not possible to do the situation for real, you do a simulation using technology, probably computers. Let me give you an example. And I think you should agree that it should be done using simulation, not the real thing. Automobile manufacturers use simulations with dummies to study the effects of crashes on humans. They don't put really humans in the cars, guys, and make them, just do the to figure out the effect, of a crash. I wouldn't do it even for millions. Because what about if you don't get out of this, just safely? And they're doing it to figure out whether the person will get out safely. So they use dummies. Okay, now we're going to do 4 examples, and you're going to tell me which is which. So consider the following statistical study. Which method of data collection would you use to collect the data for each study? Remember, we have observational, we have experiment, we have survey, and we have simulation. Number 1, a study of the effect of changing flight patterns on the number of airplane accidents.
Simulation.
Yes. They're not going to put 2 planes in the air, guys, and have them collide just to see what's going to happen. So it's a simulation, computer model. Number 2, a study of the effect of eating oatmeal on lowering blood pressure.
Experiment.
Yes, it is an experiment. And here's how they should do it. They bring 2 groups. They pay probably. Sometimes it's not volunteer. It's just they paid people. One group will be asked to eat oatmeal for a while, probably a month, 2 months, 3 months. Another group will just continue doing it, just without the, doing their diet without the oatmeal. They will take their blood pressure, of everybody who participated before the study, And then they'll take their blood pressure after they conclude the study, and then they determine whether oatmeal helped lowering blood pressure or not. Number 3. A study of how 4th grade students solve a puzzle.
Observation.
Yep.
Observation.
I couldn't agree more. I think you know the difference, guys, between the 4 categories. And then a study of US residents' approval rating of the US president.
Surveys.
It is a survey. Usually they survey us, even over the phone or a form that you fill out. It's a survey. Any questions so far? All right. Lots of terminologies, guys, as I told you in the first chapter. So, okay. This, you'll not be assessed on that, but I just want to tell you what a confounding variable is. That's an important thing that you need to know, but that will not be assessed. Confounding variable occurs when an experimenter cannot tell the difference between the effects of different factors on a variable. So I'm going to give you this example. Look at this example right here. A coffee shop owner remodels her shop at the same time. Okay, the coffee shop owner decides to remodel her shop because she or he she wants, you know, just to generate more profit and more revenues at the business. Remodeling is a good thing, will attract new customers. But look what happened. At the same time, a nearby mall has its grand opening. If the business of the coffee shop increases, it cannot be determined whether it is because of the remodeling or the new mall. Do you agree, guys, with this statement that it could be that the new mall opening that generated more traffic and that led, you know, to more business at the coffee shop, or it could be the remodeling as well? Do you guys agree with this statement?
Yes.
Yeah. So what does that mean? It means that the owner remodels and was hoping that this is going to increase, you know, just profit, but something else happened without the owner wasn't aware of, that the mall opened there, a nearby mall, you know, just open. So the nearby mall is called the confounding variable because that's a variable that was not taken into consideration, you know, just when the coffee shop owner remodels the place. That's what a confounding variable. So it's a third-party intervention, guys, that you're not aware of. It's in the background. It's working in the background. You don't know about it. Statisticians always have to think of this, that if there are some confounding variables that affect, you know, just their study. Now, let me tell you something about the placebo effect. And actually, I heard that from a lot of people. Placebo means a sugar pill. It's nothing. I know of some people, guys, then when they get sick, they go to the doctor, and even the first day they start taking a medication, you know, they start feeling better. Just the psychology that I went to the doctor, he assured me nothing is wrong with me, they start feeling better. This is the placebo effect. A subject reacts favorably to a placebo, and in fact, he or she's been given, you know, no medical treatment at all. Just sometimes the assurance that you're doing something, you're taking something. And people who take the placebo when they go through experiments, they're not even told that it is a placebo. They probably think it is an actual treatment. And then they start feeling better as a result of this thought. And blinding technique, it's when they do experiments, if you don't tell the subject whether he or she is getting the treatment or placebo, it's called the blinding technique. It's a good technique. Probably they've done that, you know, when they did experiment on the vaccine. I'm not sure how this was done, but probably it was done this way. Okay. What you need to know what a sample size is. Sample size is the number of subjects in the sample. And this is very important to experimental design. For example, guys, If I have 30 students in my class and I want to pick a sample, I should not pick 25. That would be a very large sample comparing, to my population. But if you have like 100,000 people and you want to pick a sample, you should not pick 10 or 15. That would be too low of a sample. It has to be an adequate sample size to represent the population. So probably it should be in the hundreds or the thousands. Okay. And now the last thing, guys, in this chapter, we're going to learn about sampling techniques. What are the techniques that statisticians use to draw their samples? And that's very, very important, guys. They will have a lot of questions on the homework on sampling techniques. The first type of sample, which is the very best, it's a random sample. A random sample, every member of the population has an equal chance of being selected. So let me ask you guys, I have 27 students now. If I want to pick 5 students at random, can you give me an idea how I can go about doing this? What use, and turns out to be a random. So give me an idea that goes in line with this definition, right?
Yeah. I think, like, for example, if we all write our names down, like on a stick, and then we mix it in a cup, and then you just randomly close your eyes and pull out the cup.
You got it. You got it. Exactly. Put the names in a basket and select five names without looking. That's it. Very good. That's the best. If you're doing something, by hand, that would be the best thing, guys. If you have 100 people, put their names in a basket and pick 6 or 7 or 10 or 15. That's random. You can't just look at the name before you select them. You should not be looking at the names. So that's a random sample. Now, let me tell you what a simple random sample is. Let's say we want to pick, just 5 students out of a group of 30 students. A simple random sample means every possible sample of the size 5 has the same chance of being selected. And again, guys, the best way to get a simple random sample is to put the names on the basket and just select 5 names out of the 30. That would be a simple random sample. So every possible sample of the same size has the same chance of being selected. Keep this definition in mind. Now, guys, I'm going to show you a scenario of an example that turns out to be not a simple random sample. And I would like you to tell me why this is not a simple random sample. So just one sec. Let's say I have you in class in person, and we have 6 rows of tables, and 5 students are seated in each row. So I ask the students to prepare 6 pieces of paper and write the row name on each one. So he will write row 1, row 2, row 3, row 4, row 5, row 6. We'll put them in a basket. And definitely the row number are hidden. You can't see them. And then we'll ask the students to pick 1 piece of paper. And then the students pick, like, let's say row 2. And then we tell students in row 2 that you're going to make the sample. All the students in row 2, which is 5 of them, I need 5 anyway, they will be the sample. This is not a simple random sample, what we just did. And let me just put it again, the definition. Every possible sample of the same size has the same chance of being selected. The way I did it here, guys, this is a violation of the definition of the simple random sample. Can you detect this violation?
There isn't the same amount of students in the rows.
Yeah, there is. We put 5 in each.
Oh,
That would have been an issue, yeah, if it wasn't, but assuming it is. This is not a simple random sample, and you should not be doing this to get a simple random sample.
You left all of the rows. You didn't use any of them.
Which ones?
You didn't use any of the rows except for 2. So you left the majority of them.
But we picked one at random. It doesn't matter. We just picked one row at random. So it was random sample. Let me tell you what the issue is. A simple random sample, guys, means that any 5 students should have the chance to be in a sample together. And actually with this, it's not possible. Then let me tell you why. Do you think, let me take the students who sit here and that one who sit there and this students who sit here and one student who said that's a 4, that's a 5. Do you think based on the technique I used that those 5 students will ever be in a sample together?
No.
No, because I'm picking by rows. Those students belong to 5 different rows. So how I'm going to put them together? That is a violation of definition of simple random sample. So guys, the best way to pick a simple random sample, look what you do. You put the names in the basket, all the names, name 1 to name 30, all of them, and pick 5 names, and that's a simple random sample. That's what a simple random sample. All right. Now I'm going to show you how you can use tables that are provided in the book with some of the exercises to pick a simple random sample. Let me show you that. There are 731 students currently enrolled in statistics at your school. You wish to form a sample of 80 students to answer some survey questions. So we need 8 out of the 731. And guys, I don't have time to write down your names, 731 names, and put them in a basket. That might take a lot of time, kill the entire class time. Is there a faster way to do it? Well, definitely with the use of technology and other means, there is a way, just to do that quickly. And I'm going to show you one way to do it by hand. And then I'm going to show you how the calculator can do that for me. So look what we do, guys. We're going to assign a number to each student from 1 to 731. Since 731 is a 3-digit ID, we should be fair with all students, and all students should have a 3-digit ID. So what would 1 be as a 3-digit number, guys? How can I make 1 a 3-digit number?
Just put 001.
Yeah, 001, 002, 003. And then when you come to 10, it's 010, 011, and so on and so forth. Exactly, because you have to be fair. Everybody has a 3-digit ID, and now we have 3-digit for everyone. And let me show you guys something that you probably could see in one of the homework problems. Show you how to pick the 8 names. Look. Okay. There's an arrow. This is called the random numbers table. There's an arrow there. It's asking me to start right here. Look what we're going to do, how we're going to use the table, guys. We're going to read the table 3-digit at the time. If the 3-digit is between 1 and 732, then the person will be in the sample. If it is not, then the person will not be in the sample. Because remember, we numbered the students from 001 to 732. Or 31. All right, watch. Let's read the first 3-digit. 719. Is 719 a number between 001 and 731? If you say yes, then this student is in the sample. So I will call upon the students whose number 719 and tell the students you're going to be in my sample. Let's read the next 3 digits. You can do it in a row. 662, yes. That's in the sample. What about this one, guys? 738.
No.
No, because I don't have anyone by the name 738. We go up to 731. Move on. Next. 650. It will be in the sample. Now, maybe some of you were wondering, does this table pick single digits? Yeah, it does. Look at the next one. 004 in the sample. I need 4 more. We'll continue. These 3. 053 in the sample. Next. 589 in the sample. That's less than 731. So I got 1, 2, 3, 4, 5, 6. I need 2 more. 403 in the sample, and then 129. And that's it. You got your 8. This is called the random sample. If you ever see this in the homework, guys, they will tell you exactly where to start is, and you just start counting exactly as I did here and get the numbers. This is called the random table generator. I want to show you how we could do that using technology if I have to. Watch. But I won't ask this a question like this on the test because the calculator, every time I use it, is going to give you different 8 people. It's not going to give me the same 8 every time. And watch, this is how it's done. Just go to math. And you go to probability. And then it's number 5. It says random integer. Integer is a whole number. Okay. My lowest ID for a student is 1, and my highest is 731. And I want the system to get me 8 of them. I can do more than 8, less than 8, whatever. Just hit paste and watch, guys. I'm gonna quit my job if I get the same numbers that I put those, because that would be almost impossible. So these are 8 the numbers, guys, that you get. Does any of them even match with what we have? None of even them. It won't happen. It's like winning, you know, just a jackpot or even lesser chance. Any questions here?
So the order matters though, like when you're going from
No,
the
the order doesn't matter which one is picked first because they're gonna be all together.
So like, can I do 917 for instance, and then like 671?
Oh,
Can they-
no, yeah, the order matters and how to read them. Exactly. No, if that's
Okay.
what you're referring to, it does matter. Yeah.
And like,
But
is this
but
when
you
they,
know what? If it is a question on the test, it does matter. But for you, it doesn't matter how you want to do it, as long as you do it randomly.
okay.
As long as you do it randomly, it doesn't matter. But an easier way just to read it, just from left to right. So this is the, look, guys, if I try to do it again, a student asked me to do the steps again. So let me show you. You just go to math, go to, oops, I skipped this, probability. I go to number 1731, and then I need 8. And watch, guys, we're not gonna get the same numbers that we got earlier. That would be impossible. See? And don't underestimate the single digits. They might show up. There's a 5 there. Oh no, 531, sorry. These are the numbers. What I do is scroll back and forth. And do it for the 3rd time, you will not get the same numbers again. Watch. So if you want to play the lottery, guys, and you want to pick numbers before you go, you can have your calculator pick them for you. You will learn that in chapter 3, how to do this. So, all right. Other sampling techniques. There are 4 more sampling techniques. So you learned about random sample. That's the first technique. Second technique, guys. It's called the stratified sample. And to collect, should not be there. To collect a stratified sample of the number of people who live in Westridge, that he starts with an example. Households, you could divide the households into socioeconomic levels. So you say you have a population. You split up the population into pieces, And then you go and get people from each piece and put them together in one pool to make the sample. That's what stratified is. And the example says here, to get a stratified sample of the number of people who live in Westridge County households, you can split up the counties into 3 categories: low-income people, middle-income people, and high-income people. You go to the low income and you select a few from there. You go to the middle income, you select a few. You go to the high income, you select a few. All people who are selected, you put them together, and that will make a stratified sample. So divide a population into groups. They call them strata, and then select a random sample from each group. I like you to notice, guys, that more people were selected from the middle income than the low income and the high income. Can you guys tell why? And that makes actually sense. That should be the case.
Because they represent the median. I don't know.
Not necessarily. Then we're being biased here if we take more.
Maybe because the standard deviation will be a lot if the less people were selected.
Boy, I don't know anything about standard deviation. I'd like you to look at the pictures and tell me.
Because they're the majority.
Because there is more middle income people than low income and high income. You can notice, guys, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. That's why we picked one more.
They're the majority of the population, yeah.
Yeah. You guys have to be fair. Let's say I have 20 male students and 10 female students in my class, and I want to pick a sample. If I want to do a stratified, I have to pick twice as many male as female because they are they're double the number of female students. That's
Is
how.
it like the House of like representatives held based off of
Yeah.
population? Okay.
Yep, based on the population size and characteristics, definitely. If the overwhelming majority of Westridge County households are low income, then there should be more low income people, just in the same. And that's what we call diversity, guys, and inclusion. That's how you try, just to honor that and enforce that. Cluster. You divide the population into groups. Watch here, like zip codes. And select all of the members in one or more, but not all of the clusters. So here, the groups are called clusters. Before they were called stratas for stratified. And here's an example, guys. In the Westridge County examples, you could divide the households into clusters according to zip codes. And then select all the households, let's say in zone 1, everybody. That's what a cluster is. So if you want to do a cluster here for this example, you just go put them in different incomes and select the entire group 1 or entire group 2 or entire group 3. But that wouldn't be fair to do it, just with this example. Because if you select, just a cluster sample here, let's say you just pick low income, but then middle income and high income have no voice in the sample. So stratified would be better, just for this situation. Here, if you split up the area into zip codes and select everybody who live in a certain zip code, that could be a good sample. If all people in all the zip codes share very much the same common characteristics, then it would work well. But that's what a cluster is. So I give you an easy example. If I want to do a cluster sample, like I can split you up, guys, into 2 groups, female and male students, and pick all the female students to make a cluster sample. That wouldn't be a good sample, but that's called a cluster sample here. Systematic. You choose a starting value at random, then choose every kth member of the population. I'm going to give you an example. It's very easy. When you see that, you should easily, guys, recognize whether you have a systematic sample or not. I'm going to give you an example that you're going to see all the time in the exercises. Let's say I want to select 5 students from my class for a sample. You're coming to class, your class starts at 9 a.m. So I say the students who walks in at 8:55, I'm going to put that students in the sample. And then every 50 students who show up will be in the sample. So 8:55, one student shows up. I'll tell him or tell her you're going to be in the sample. Then 9 o'clock, I'll tell that person, you know, they're going to be, or every 50 student. So I'll count 1, 2, 3, 4. The 50 students who show up, I'll tell that students you're going to be in the sample. Then the 10th, then the 15th, then the 20th, and so on and so forth. This is what a systematic sample is. And let me show you an example, guys, here. There's an example. In the Westridge County examples, you could assign a different number to each household. And then randomly choose a starting number and then select every 100th household. So you choose a starting number and then you count every 100th household and you put them, you know, just in the sample. That's another example. Convenience sample. That's the last one. That's often not recommended. It leads to biased studies. Chooses only members of the population that are easy to get. I'm going to give you an example, guys, of a convenience sample. Let's say I want to do a survey in my class on the distance that students commute from home to school. So it's January. It's very bad weather outside, snowing heavily. Only 5 students showed up to class, and I did. So I go and tell those students, you're going to do the survey on the distance you commute from home to school. Just few questions. This is a convenience sample, guys. And can you tell me why? It's biased. It does lead to biased results. What do you think? What's wrong with this one? What do you think the kind of bias that I'm going to get out of this survey?
Can you repeat the question again one more time?
Yeah, we're going to resume recording now. Yeah. And then you know what the bad news about this, that I'm going to make a conclusion that in general my students commute a short distance to school, and that's not true, but it was based on the sample. And probably this should alert you guys that not everything that you see being marketed is true. Some of them could be based on convenience samples. So I want you, just to try to start, questioning, just what you see and what you observe now. You are doing a study to determine the opinion of students at your school regarding stem cell research. Identify the sampling technique used. So remember, we have random sample, stratified, cluster, systematic, and convenience. Which one of those it's going to be for the first one? You divide the student population with respect to measures and randomly select and question students from each measure. So we'll divide it like this. Math, chemistry, biology, social science, etc. And then we pick people from each one and put them in the sample. What is this, guys?
Stratified.
Yep,
Stratified.
I agree. You assign each student, be careful here, don't rush into the answer. You assign each student a number and generate random numbers. You then question each student whose number is randomly selected.
Simple random?
Yes. Why did I say don't rush? Because I don't want students to say systematic. Systematic, yeah, it's you pick every fourth or every fifth. Here, there is no system. He said you generate random numbers. Once you see this word, guys, this is a simple random sample right away. Assuming that the program on the calculator is not biased, it's not like programmed to pick only larger number, smaller number. That's the assumption here. So this is a simple random sample. The last few pages, guys, have a summary. I would like you actually to check whether you understood the whole thing today. Is just check out my summary of chapter 1 and all the definitions that we did. You can see that here. Observe all here. It's these are not required right here. We didn't cover them, so you can omit them, but I just put them in there. Oh, this is the experimental design that's included there. That's not, you don't have to worry about that. We talked about the confounding variable, the placebo effect. There will not be any questions on those. And these are the sampling techniques that you learned today. Random sample, simple random sample, stratified, cluster, systematic. And I didn't put convenience because it's not very important, actually. We should not be using convenience sampling. Okay. And that